In this type of problem, we have 8x to the third a squared and then minus 18x to the third b squared. So let's check if we have a common factor between these two terms. So between them, the 8 and the 18, they're both even, so they're divisible by 2. In addition, they also have the same variable x to the third. So I'm going to divide both terms by the x to the third. So my GCF, 2x to the third, that's why I'm going to divide both terms. So it's going to be outside the parenthesis. 8x to the third a squared divided by 2x to the third. So the x to the third will divide into 1. Then a divided by 2 is 4. And I have left is the a squared. And then minus. So again, the x to the third divided by x to the third will become 1. Then 18 divided by 2 is 9. And I'm left with the b squared. So I'll put it next to the 9. Close parenthesis. Alright. Next, let's take a look inside the parenthesis. Can we simplify this? Can we factor even further? So it's 2 terms with a minus. Take a look at the first one. It's 4a squared. That's a perfect square. So let's check the second one. 9b squared. Another perfect square. So this right here is a difference of square. So simply, I'm just going to do the square root of the first term and the second term. So the square root of the first term, 4a squared, is going to be 2a. And then the second term, the square root of 9b squared will be 3b. So this is my a value, this is my b value. So I'm going to set it up according to the format that we covered in difference of square. So it will be 2a plus 3b in the first set, and in the second set it will be 2a and then minus 3b, and then close parenthesis. And then I'm going to bring down my greatest common factor, 2x to the third power. So 2x to the third power. So this is my full answer, completely factored out. So 2x to the third times 2a plus 3b times 2a minus 3b. So this is our final answer. So in this next example, I have 12m squared x squared minus 36m squared xy plus 27m squared y squared. So let's check if we have a common factor. 12, 36, and 27, they do have a common factor. They are all divisible by 3. So I'm going to divide each term by 3. In addition, I noticed that there's an m squared in each term, so I'm also going to be dividing by the m squared. So my greatest common factor is actually 3m squared. So that's going to be outside the parenthesis. So 12m squared x squared divided by 3m squared. The m squared will divide into 1. Next is 12 divided by 3, which is 4. Then I'm left with the x squared because I didn't divide it by anything else. And then minus, again, the m squared will divide into 1. 36 divided by 3 is 12. And then I'm left with the xy since I didn't divide it by anything. And then plus, again, m squared will divide into 1. 27 divided by 3 is 9. And I'm left with the y squared since I didn't divide that by anything. And then close parentheses. So let's take a look. Can we factor the inside, the 4x squared minus 12xy plus 9y squared? So it might be a trinomial. We can factor that as the method for trinomials. Or take a look at the first term and the last term. 4x squared, that's a perfect square. In addition, 9y squared is another perfect square. So if we were to do the square root of 4x squared, that would be 2x. And then if I were to do the square root of 9y squared, that would be 3y. So if I were to check 2 times my a value, which is 2x, times my b value, which is 3y, and then this is again a method to check if this is a perfect square. 2 times 2x is 4x, and then 4x times 3y, that will be 12xy, which match with the middle term. So this is indeed a perfect square. So I'm going to factor this according to the format that was covered in perfect square. Since the middle term is minus, so it's going to be my a value, 2x, and then minus my b value, which is 3y, put in parentheses with the square. In addition, I'm bringing down my greatest common factor, which is 3m to the second power. So that's my fully factor out or factor completely answer. So 3m squared times the square of 2x minus 3y. So let me box it up. And then this is our final answer.